Hello students, welcome to Competitive Exam Library YouTube channel. Today we are going to see what is the time response specifications of second order system. Second order systems. So this is the question, how it is going to respond the time response of the specifications of second order system. We are already know in time response we are having transient response as well as the steady state response. There is no much discussion about the steady state response, because after reaching the final value we will call it as the steady state response. But meanwhile, whenever we have taken this transient response, it is having some specifications which will define the transient response of the any system given. So that specifications are important in deriving the transient response of second order system. So in this concern we are having, so there are some specifications are there. First is starting with delay time, then we are starting with the rise time, then we are starting with the peak time, then we are having the maximum peak overshoot, then you are having a settling time finally. So these are the different time response specifications of the second order system. Let us write one by one. So first we will consider, let us consider the second order, let us consider the system here with first one I am considering here, that is so first one will be here delay time, we will call, that will be represented as TD. Second one we are taking it as rise time, that will be normally represented with the TR here. Third one will be peak time, that is TP here. Next, fourth one is maximum peak overshoot, that will be MP. Next, fifth one will be settling time. So these are the different specifications which will define the transient response of second order system. Let us take one by one. Let us start with the what is the meaning of delay time. So delay time I am going to define here, delay time. So delay time is defined as the time taken for the response, to reach 50% of the final value, 50% of the final value at the very first time. We are going to call it as the delay time. So that is the definition of the delay time, what it is given. So the time taken for the response to reach the 50% of its final value. So see here, so this is the what 50% here. So the time taken here, this is called as the delay time. So this will be represented as delay time, which is defined here 50% of its final value, that is called as the delay time. Next we will consider another thing will be here. Second important one is, that is rise time. Second one is rise time. In this video we are going to study rise time derivation also. So, next derivations we are going to study in the other videos. See what is the meaning of the rise time here. So, rise time is definition as, so let us take the rise time definition. It is defined as, the time taken to reach output from 0% to 100% in the first attempt. So, that is called as the rise time. So, rise time will be, normally we are going to represent it here. I will show here rise time. So, this is the rise time here. So, the time taken here, see here, that will be reaching here, this is the point, will be reached to 100%. So, normally it is reached to 100%. So, we can write that as, so TR C of t for rise time, t is equals to TR or t is equals to TR. What is C of t? C of t we have taken it as, that is at t is equals to TR, what you are getting, 100%. That means 100% means 100 by 100, that is equals to 1. So, let us equate that C of t value. So, C of t is equals to, we are already got the response, that is 1 minus e to the power of minus zeta omega n t divided by, here T r we are considering, that will be under root of 1 minus zeta square into sine of omega dt r plus theta, that is the response at t is equals to T r. Now, you have to equate this response equals to 1. So, minus zeta omega n T r divided by under root of 1 minus zeta square sine of omega d T r plus theta is equals to 1. So, this side you bring this term to this side and this one to this side, then what will happen? 0 is equals to e to the power of minus zeta omega n t whole divided by under root of 1 minus zeta square into sine of omega d T r plus theta. So, here also T r. Now, you got this. So, how you can make this? If you observe here, in this we are having two parts here. One part will be, this is the value, and another part will be is the, so this I am taking it as the second part, this I am considering it as the first part. So, first part, so for satisfying the equation, either first one should be equals to 0 or second one must be equals to 0, but definitely first part, that is e to the power of minus zeta omega n T r divided by under root of 1 minus zeta square will not become 0. Why? Because T r is a finite value. So, T r is a finite value here. So, it will not become equals to 0. That means, first part will not become 0. So, let us make the second part equals to 0. We will make that second part, that is sine of omega d T r plus theta is equals to 0. How we are going to satisfy? By considering the trigonometric functions. So, that is equals to sine of n pi. So, sine will get cancelled, omega d T r plus theta is equals to n into phi. So, omega d T r is equals to n phi minus theta, T r will be n phi minus theta divided by omega d. Or we can write T r is equals to n phi, theta can be written as tan inverse of under root of 1 minus zeta square divided by zeta divided by omega n into under root of 1 minus zeta square. Like this also we can write. So, let us consider when n is equals to 1, T r can be written as phi minus tan inverse of under root of 1 minus zeta square divided by zeta whole divided by, you are going to get omega n into under root of 1 minus zeta square. So, this is the formula of the, what is the formula here? This is the formula of zeta, that is rise time. This is the formula for rise time you are getting. So, very important derivation. That is all in this video. If you like this video, please like, share and subscribe the channel. If you have any query, please make comment in the comment box. I can reply. Thank you very much.